South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history, and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare, and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
Good morning, good morning. We are coming to you live from Portland High School in Dale Mitchell's Plain. I'm Khalid Kungani Kivaspati, your host for this grade 11 Pure Maths workshop. Obviously, yesterday we were here and we had a fantastic day where we were doing maths from 8:30 in the morning up until 3 p.m. If you're just joining us online, make sure that you ask, questions that are related to the sessions today, so that we can give you those answers and we can give those questions that you will be asking to Mr. Kota as well. But just to have a few words to get us going this morning, we have Hasanain Abdullah from Awqaf SA, just to give us a few heads up just before we kick off the session.
Good morning, good morning, good morning. Welcome to the Maths Workshop hosted by Awqaf South Africa, and also jointly we're coming to you live here from Portland High School. This is a joint effort supported by the Western Cape Education Department, and we want you and also to give you an edge in preparation for your maths examination. Please do be advised, these sessions are hosted on Awqaf's YouTube platform, so you can refer back to these sessions on the YouTube platform. You can subscribe at Awqaf South Africa. So Mr. Kota will be doing Maths Paper 2 today. So interact with Mr. Kota and take full advantage of this. Good luck and all the best.
Thank you, Hasanain.
Mr. Kota, just before we get going, what is it that we need for today?
Today you need your scientific, your scientific calculators. You need your stationery. You need some hydration, and you just need a good attitude. Sorry, that's the morning. That's my morning cough. Right, guys, let's go. Let's get started. Let's get started. Welcome, welcome, welcome to all our onliners and all our on-siters. We are into paper 2. We had a bumper day yesterday. We covered the whole of algebra. We did the whole of functions yesterday. We did it in detail. I hope you guys had an opportunity while watching the football yesterday to actually sit and go through all the math. Very disappointing evening for many people in South Africa, whoever was supporting, well, the losing side. But yeah, a beautiful morning here, a beautiful misty crisp morning here in Cape Town. And I just want to welcome everybody. Guys, we're starting with paper 2. Let's go. We have analytical, trig graphs, Euclidean, 100 marks. And take this diagram down. Let's get ready. Let's get ready. So take the diagram down. I hope the screen is up. No. Coming up, coming up, coming up. Let's go, let's go, let's go. And we are live. So we start with analytics. This is paper 2. We're going to start with analytical. I'm going to go straight into past papers. Analytics, trig graphs, and Euclidean. Guys, if you pay attention to what I tell you today, and if you listen carefully, we're actually going to go through the KZN June paper of 2024. Right? I'm going to use that as a template. And then I'm going to choose different papers, and we're going to, this is full preparation for your June. It's not only for June, it's for June and finals, right? This is your content for the year that is required of you to master. Okay, guys, let's start. So they give you a point here, D, -10 and 6. Take this one down. Welcome, onliners. Hit us in the comments from which school area you are calling in from, or you are tuning in or dialing in from. We've even got educators that are on the now this here looks like it's on the axis, but let's just put K there. That's O, the center, that's E, that's F. Okay. The vertices of a quadrilateral point, the diagonals of the quadrilateral bisect each other at K. The diagonals bisect each other. They say the diagonals bisect. Now, what does the word bisect mean? What does the diagonals bisect? What does it mean? cut in half. Yes or no? The diagonals bisect each other at K. The equation of the diagonal. The diagonal's equation is 3x minus y plus 6 equals 0. Y is equal to mx plus c. Y is equal to mx plus c. Now, you might ask, analytics, how many marks? Generally in your June exam, analytical geometry, you'll probably get one for 12 marks and one for 17 marks. So you'll get question 1, question 2, and that would be a total. So you're looking at plus minus 30 marks. It's 30 marks that you cannot throw away. For the tail enders, if your paper is out of 100, if you only scored 100 in analytics, you've passed. Well, you know South Africa's pass rate. I don't need to tell you. If you write your name, you get a mark. South Africa, if you spell your name correctly, you passed. Leave that. You might even get a job in government. Right, I'm just going to rewrite this here. 3x minus y plus 6, 3x minus y plus 6 equals 0. That is the equation of the diagonal. So let's go calculate the size of angle beta. Right, so now we got, now just to show you where's angle beta, right? I'm going to put angle beta, I'm going to change it slightly. And I'm going to put angle beta here. I'm going to put angle beta there. I'm going to add on another question, and I'm going to call this angle alpha. So I'm taking the same question paper. I'm tweaking it a little because I'm giving you my own values. I want us to master the whole analytics based on this one question. Right, question number 1. Let's go. Let's do it question for question. They want the size of angle beta. Now we all know, come on guys, this is analytics. What formulas do we need to know? Right, number 1, besides this, maybe somewhere else, you don't need to write it here on the side. Which are the only formulas you need to remember? You need to know your distance formula, yes or no? And we all know the distance between 2 points A, B is the square root. Remember this, x2 minus x1 all squared plus y2 minus y1 all squared. There was a memo that came out this week, full instruction to schools. I know in Gauteng. Do not issue learners with a formula sheet. The formula sheet will only be given in final exams, grade 12. That was Gauteng. I don't know whether it has been effected here in Western Cape already, but I think that was the best thing they could have ever done. Yes, you don't need a formula sheet. You need to remember your formulas. These formulas are easy to remember. You need to remember every formula with regard to every topic, so it will make your life a misery. Imagine you're going to war, you're going with a whole lot of weapons, and every time you need to go and fight in a situation, you need to look at the manual to see how to use the weapon. My friend, you're dead even before the war began. Your formula are your weapons. Without the formula, you can't do the topic. Forget about the formula sheet. That's your TV manual. How many times when you bought a cell phone or you bought a TV that you had to open up the manual every time you needed to switch it on or change a channel? Don't be ridiculous. Throw those formula sheets away. Remember it. Know what the hell you're doing. Every time you need to download an app, do you open up your phone? Do you open up a manual and say, oh, okay, no, let me open this. The manual says flip the screen. The manual says press this button. The manual says go to play. Listen, then you are a retard. Know your formulas. So your distance formula. Then the next formula we need to know is our gradient formula. And we all know our gradient, the m of AB is equal to y2 minus y1 over x2 minus x1. And where do we use? We know for parallel lines, the gradient of line 1 is equal to the gradient of line 2. For perpendicular lines, the m of line 1 times the m of line 2 equals how much? Very good. So you know it. You're just lazy. You don't want to remember it. We know tan of angle theta is equal to the m of the line. That's the angle of inclination. We also know for collinear points, where the points lie in a straight line, if you got point A, B, and C, to see whether they are collinear, then the m between these two must equal to the m between those two. So you got your distance formula. You got your gradient formula. What's the next formula we need to know? Excellent. So why do you need a formula sheet? Burn it. Use it for toilet paper. Wipe your ass with it. x1 plus x2 over 2. y1 plus y2 over 2. And then the equation of a straight line, y equals mx plus c, or if you're given a point and the gradient, y minus y1 equals m into x minus x1. Have you seen this formula? You'll be using all this right through until grade 12. This is 11 and 12. Next year, you're writing on the same work. Nothing's changed. There'll be another topic called circle analytics, but that's a different topic. As far as analytics goes, this is what you need to know. So what we're doing today is not only preparing you for today, guys, it's preparing you for this year and next year. Are we all on the same page, grade 11s, or am I talking Japanese? Yeah.
Awesome.
Danko. Let's go. Let's go. Right, you all took it down. You got your formulas, right? Right, let's start. We're going to break this question up into every humanly possible question you can get on this. Then you go for break. We come back, then we're going to do twigs. And then we're going to start with reduction, triangles, substitution, identities, general solution. Okay, let's go. The size of angle beta. Let's start. Onliners, how are we doing? Morning, good morning. Right, let's answer here. The size of angle, guy, it's fine. Thank you, Khalid. Right, the size of angle beta. Now, we don't have this. This point here, we know our x value, we don't have it. Our y value there is 0. Right, they tell you in the diagram D minus 10 and 6, E, F, G, 1 and 9 are vertices of a quadrilateral. F is a point in the x-axis. The diagonals of the quadrilateral bisect each other at K. The equation of the diagonal is 3x minus y plus 6 equals 0. B is the angle of inclination. Okay, in fact, okay. We've got this. I move this one up. So in fact, this angle of inclination here, the angle beta was actually standing here. It should be of this point here. We don't have the midpoint here. Let us say, guys, let's say this midpoint here, K, is minus 1 and 2. Okay. Now, how are we going to find angle beta? We first need F's coordinates. Guys, we first need F's coordinates. So if this is the midpoint, if K is the midpoint, How do we find f's coordinates? We use the midpoint formula. So we say x midpoint is equal to x1 plus x2 over 2. We say y midpoint is equal to y1 plus y2 all over 2. So what's your x midpoint? Minus 1 equals x, right? We actually don't need the y. We're solving for the x. So in fact, we don't need that side. It's x minus 10 over 2. Multiply both sides by 2. Minus 2 equals x minus 10. X is equal to minus 2 plus 10. X is equal to 8. And we've got the y value there is 0. So f's coordinates is 8 and 0. Here we go. Here we go. F's coordinates, let's go there, is 8 and 0. Are you all with me, guys? What do you mean? No. We're using the midpoint formula. Dude, were you at school this year? Right. I'm calling this one was x1, y1. No, that's x midpoint, y midpoint, x1, y1, x2, y2. Right? Now that we got f's coordinates, we can now find the gradient because we want the size of angle beta. Angle beta is from your x-axis up, your angle of inclination. We don't use sine, we don't use cos. What do we use? Tan. Very good, the angle of inclination. So we want the size of angle beta. We want the size of angle beta. Right, let's do it together. Let's do it together. So we can say tan of angle beta is equal to the gradient of GF or FG. So tan of angle beta is equal to y2 minus y1 over x2 minus x1. Yes or no, guys? So tan beta is equal to y2 minus y1 over x2 minus x1. Tan of beta is equal to 9 over minus 7. Beta is equal to shift tan minus 9 over 7. Boom. I get minus 52,12. Now, that will only indicate direction. So now 52,12 is an acute angle. It's less than 90. But we know that beta is greater than 90. So it's an obtuse angle. So you got an acute answer. Your angle is obtuse. How do you get an acute from an obtuse or an obtuse from an acute? Don't you say angles on a straight line add up to how much? Right, so how much is beta? Therefore, beta is equal to 180 minus 52,12. What's our final answer? 127,87, 127,9. There we go. 127,9 degrees. Yes. Where does a minus 1 come from? K's value. K is not on your y-axis. K, I gave you its coordinates. It's not drawn to scale. K is minus 1. No ways. I am repeating. You just joined now and you want me to repeat from the beginning. You're joking. You got jokes. Right. So here we go. Here we go. So that is angle beta. Right. Calculate, right? Let me erase all of this. So we're done with that. We're done with that. Okay. Question number 2. Question number 2. I want the coordinates. I want the coordinates of E. I want the coordinates of E. Right, again we're going to be using the midpoint formula. Why? The midpoint is given -1 and 2. It's not drawn to scale. I know it looks like it's on the y-axis, but it's actually not. Okay, let's go. So E's coordinates again, x midpoint is equal to x1 plus x2 over 2. Y midpoint equals y1 plus y2 over 2. So x midpoint, now we're going to be using G and K. So x midpoint -1 equals x plus 1 over 2. 2 equals y. 2 equals y plus 9 over 2. Solve for x and solve for y. So -2 equals x plus 1. X equals -3. So that's -3. And then 4 equals y plus 9. Y equals 4 minus 9 is -5. And that's -5. There we go. Simple, straightforward. You got 3 marks, 3 marks. Okay. The next question for 5 marks. Find angle alpha. Find angle alpha. Right, question number 3. Those of you who have started, who have taken this one, some of you write quite fast. Question number 3, find angle alpha for 5 marks. Start with that one. Here's alpha here. Now I'm going to show you a trick. I'm going to show you a nice trick that you can use even in grade 12. You see, alpha is not against your x-axis. The angle of inclination is usually calculated from your x-axis up. Yes or no? So you know what you do? Come, I show you something nice. You shift your x-axis. You bring it right down to the point. So you move your x-axis up or down. Check here. You take your x-axis and you drop it right till the point there. You drop your x-axis till that point. There we go. So you can move your x-axis up or down to the point where the angle is. Are you listening to me? I know many of you haven't seen this before. Many of you don't know about the system. But what you can do is you can move your... So if it was here on the top, you could draw your x-axis on the top. If it was here at this point, you can draw it at that point. But it's here at point E. So I drop my x-axis right up till that point. Why do I do that? I'll show you. Because then I can calculate from the x-axis up to this line. I can call that alpha 1, big angle. Then from my x-axis up to this point, using this line's gradient, I can call it alpha 2. Big angle minus small angle will be my angle in the middle. So if this big angle is 100 and this small angle is 70, 100 minus 70 is how much? 30. So can you see how we're doing it? So you drop your x-axis right until that point. Then you make big angle, small angle. You subtract the two and that will give you alpha in the middle. So let's all do it together. Watch here. So in your exam, drop it. Alpha 1, alpha 2. So let's calculate alpha 1. Tan of angle alpha 1 equals the gradient. Which line does it touch? GE. Yes or no? Right. So didn't we have the gradient of GE? What was the equation of that line? What was the equation? It was 3x minus y plus 6. Remember? That was the equation of line GE. That was the equation. So what is your gradient here? Minus y equals minus 3x minus 6. Y equals 3x plus 6. So your gradient here is 3. So tan of angle theta 1 is equal to 3, or alpha 1. Alpha 1 equals, shift tan 3. Go to your calculator. Shift tan 3. I get 71,6. 56, 71,6. Now it's less than 90. It's less than 90. So it's acute, and this angle is acute, so we leave it. We don't say 180 minus. Now we go tan of angle alpha 2 is equal to the gradient of line EF. So tan of angle alpha 2 is equal to y2 minus y1 over x2 minus x1. That will give me minus 5 over minus 11, which is equal to 5 over 11. Therefore, alpha 2 is equal to shift tan 5 over 11. Shift tan 5 over 11. I get 24,4. Therefore, what is alpha? They want us to find alpha. Alpha equals big angle minus small angle. Big angle, 71,6. Small angle, 24,4. 70. Here's your final answer coming up. 71,6 minus 24,4. Your answer, 47,2. And there we go. You'll get 5 marks for that. Learn this. You're going to be tested on this even in grade 12. How's our onliners doing? How can it be? No, don't worry. Okay. Right, you got it down? Let's give you the second set of questions worth 17 marks. So this was about 12 or 13 marks. I adapted it. It's not exactly according to the paper. I just changed it to suit our workshop today. Right. This was question number 1. Let's go. Let's do question number 2. Right. Let's go, guys. Draw your diagram. Draw your Cartesian plane. Draw your Cartesian plane. So we got a line going like that. We've got a line going like that to the top. We've got a line going this way till there. Then we've got a line coming straight down till there. There we go. That's your diagram. B, -3 and 4. This is A -2 -1. This here is 90 degrees. That's point F. That's O. This is C, 1 and 5. That's D, 5 and Y. D, 5 and Y. That's your x-axis. That's your y-axis. Right. Let's have fun. 17 marks. Here we go. Right. Calculate the length of AC. Where's Smith? I'm getting echo here. A reverb. The length of AC. So question number 1, they want the length of AC. Let's do it question for question. Right, come on. They're asking you for the length. Which formula will I use? Distance, gradient, midpoint, or equation of a line? The obvious. Right, so AC. So AC, work it out. AC is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. AC equals the square root. Right, so we got the two coordinates. So let's say x2 is 1, minus 2 plus 2 all squared plus y2 minus 1 plus 1 all squared. AC equals the square root. 3 squared is 9 plus 6 squared is 36. AC equals the square root of 45. 9 times 5. AC equals 3 root 5. So go to your diagram and put 3 root 5. We might use it, we might not use it. But take it and put it back on your diagram. Now they want the gradient of BC. I'm going to add more questions to this. I'm going to make this from 17 marks, I'm going to make it 30 marks. I'm just going to add new questions just to show you every humanly possible type of scenario that you could get in analytics. Right, the next question, they want the gradient of BC. Work it out. This is Mahala marks. Marks for chips. The gradient of BC. Question number 2. They want the gradient of BC. So here we go. The gradient of BC. The m of BC is equal to, put your formula. They're asking you for the gradient. Put your formula, you get a mark. So the m of BC is equal to y2 minus y1 over x2 minus 3 plus 3. So therefore, the m of BC is equal to 5 minus 4 is 1 over 4. So the m of this line is a quarter. We're done. Next question. Right. Look at this. Grade 11 paper. Normally they ask you collinear points in grade 10. Here they're asking you collinear points in grade 11. Calculate the value of y if B, C, and D are collinear. So here's the question. Calculate the value of y if B, C, they are collinear. What does the word collinear mean? That they lie in a straight line. Yes or no? Good. Okay, here we go. Have fun. What did I tell you? For it to be collinear, what do we know? That the gradient between the first two, guys, because it's collinear, the gradient between these two must equal to the gradient between those two. Yes or no? So the gradient between those two is also a quarter. Yes or no? Right. So now we're going to say M of CD, MACDs, is equal to M of CD is equal to Y2 minus Y1 over X2 minus X1. So what's MACD? Quarter. Is equal to Y2, Y minus 5 over, no, yeah, Y minus 5 over 5 minus 1. So 1 over 4 equals Y minus 5 over 5 minus 1 is 4. Multiply by 4, gone. 1 plus 5 equals Y, Y equals 6. There we go, we're done. Y equals 6. Organize coffee. I got biscuits here. Right. If H is a point such that AH is perpendicular to BC, find the equation of H. All right. Right, let's see. They tell you if H is a point such that AH, now there's no H on the diagram. If H is a point such that AH is perpendicular to BC, AH perpendicular to BC, that's a bit weird. Okay, anyway, let's hear this question. Let's write it down. Let's write it down. Right, they tell if H is a point. That's the next question. If H is a point such that AH is perpendicular to BC, find the equation of AH. Find the equation y is equal to mx plus c of AH. Now let's see, where can H be? Right, AH perpendicular to BC. So I'm thinking, let's go maybe here. Maybe it's somewhere there. I'm just thinking. AH perpendicular, so that must be H. That point there will probably be point H. If AH is perpendicular to BC, right, now, in order to get an equation, what do we need? We need a gradient and we need a point. Yes or no? Right. Let's find the gradient of this line, the M of this line. Now, the M of BC is equal to a quarter. Therefore, the M of your perpendicular line, AH, is going to equal to minus 4. Yes or no? Change the sign, flip the fraction. For perpendicular lines, for 90-degree lines, change the sign of the old gradient and flip the fraction. Because that times that will equal to minus 1. Shh. You don't have to say M1 times M2 equal minus 1 and then try and find it out. No, you can go straight to it. Change the sign, flip the fraction. Done. Save you time. Save you energy. Save you brain work. Huh? Oh, you got coffee? Make there for me a coffee. Thanks, my guy. Right. Do we have a point on this line? Yes, we got. Minus 2 and minus 1. That's a semicolon. Minus 2, minus 1. Right. So what's your equation? Y minus y1 equals m into x minus x1. There we go. Let's all do it together. Y minus minus 1 plus 1 is equal to m, your new m, minus 4 into x minus minus 2 plus 2. Agreed, grade 11s? Right. Let's get it. Y is equal to mx plus c. Y plus 1 equals, multiply this out, minus 4x minus 8. Your final answer, y equal minus 4x minus 8 minus 1 minus 9. And we are done. Calculate the coordinates of G if C, B, A, G. This is E. Right. C, B, A, G. Right. Okay. Okay. Calculate the coordinates of CBAG is a parallelogram. Calculate the coordinates of G. Right. Calculate the coordinates of G if CBAG is a parallelogram. Right. There's no G on the diagram. C, B, A, G will be somewhere here, parallel to that. It will look like that. C, B, A, G. That would be G. X and Y. Right. What's the best way to find out? Are you going to calculate distances? Are you going to calculate gradients? What are you going to do? Sorry? Can't hear you? No ways. No. You show all calculations. You never go and count points on there. You do the calculation. I like how everybody just says by inspection. 5 marks for inspection. Right. The best way, listen, the best way is to use your midpoint formula. When you want to prove a parallelogram, use your midpoint. Why? The same midpoint here of between these 2 points is the same midpoint for the diagonals of these 2 points. That midpoint formula there. So if I find the midpoint here, I can use that midpoint to find G one shot. Don't use gradient. Don't use distance formulas. You use your midpoint formula and make a note of it. Highlight it as a rule. So let's do it together. Let's find this M, the midpoint here. So now AC, the midpoint of AC, we're going to go x1 plus x2 over 2, y1 plus y2 over 2. So now 1 minus 2 over 2, 5 minus 1 over 2. 1 minus 2 minus 1 over 2. 5 minus 1 is 4 over 2 is 2. So that means my midpoint is minus a half and 2. Yes or no? Right. That's your first 2 marks. A question like this can be 5 marks. 2 marks here, 3 marks for the next part. Now we need to find G's coordinates. Remember why? Because it's a parallelogram. That point, that is equal to that, and that is equal to that. It's the same midpoint for both the lines. Are you guys understanding, grade 11s? It's the same midpoint for both the lines. Now the midpoint is given. If you want to, maybe we can do it on. Okay, can I erase this first part? Let's do it together. Right. X midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. You use this formula when the midpoint is given. Make a note of this. Oh, Khalid, you're a man. You're spoiling me today, my guy. Jazakallah. Show a red carpet treatment for me today. I need this morning coffee to wake up, brah. Okay. X midpoint is minus a half is equal to x minus 3. We're using these 2 coordinates now. B and G. Minus 3 over 2. Y midpoint is equal to y1 plus y2 over 2. All right, let's just double check. Y midpoint is equal to y1. We're going to call that x1, y1. We can call that one x2, y2. Oh, so it's a 4. Yeah, it's right. 2 equals y plus 4 over 2. There we go. Multiply both sides by 2. X will equal to minus 1 plus 3. X is equal to 2. There we go. There's G's coordinates. Here's G's coordinates coming up 2. And then times 2 on this side, we get 4 equal y plus 4. Y equals 0. Actually, the point is here on the top. Right? By calculation, G's coordinates is 2 and 0. What? Times 2, 4 equal y plus 4. No, y midpoint, oh no, it's right. Y midpoint is equal to y1 plus y2 over 2 times 2 times 2, 4 equals y plus 4, y equals 4 minus 4, y is equal to 0. There we go, we're done. Right. Now they want the area. Right, let's see now. They want the area of CEOF. CEOF. They want the area of CEOF. They want the area of CEOF. Let's go, let's go, let's go. The area of C. Now they want the area of CEOF for 4 marks. So where's CE? Let's do it in a different color. CEOF. Half of the sum of the parallel. Do we have? They don't give us F's coordinates, do they? No. Because that is actually a trapezium. But we can find F's coordinates. Half of the sum of the parallel sides. Right. What is, all right. This one could be 4 marks, 5 marks, or 6 marks. Think about it. How would you calculate the area of CEOF? What is CEOF? What is CEOF? A kite. Are you crazy? Which kite looks like that? It's a trapezium. Guys, CEOF is a trapezium. So I'm just going to tilt it on its side. It actually looks like that. One pair of opposite sides are parallel. Yes. You want to break it up into 2 different shapes? You could. Otherwise, just use the area of a trapezium formula. Don't you know it? Area of a trapezium, learn this. I'm giving it to you, is equal to half of the sum of the parallel sides multiplied by your perpendicular height. Half of the sum of the... Let's double check it. It's either the sum or half the sum. Let's just double check. Area of a trap. Area. Let's Google it quickly. Area of trapezium. Yes, half the sum of your parallel sides. I was right. Half the sum of your parallel sides times your perpendicular height. So now we need the parallel sides. Shh. We know, quiet, pay attention. We know that this side's length is how much? The y value here is how much? 5. Are you all with me? It's 5, the y value. If you say you don't understand and I still need to explain to you what's a y value in grade 11, bruh, Maths Light is waiting for you. Right. Now we need the length of this side, the y value here. We got the x value here as 0. We don't have the y value. How do you find coordinates on a line? Don't we find the equation of the line, and the last value, the c value, is your y-intercept? So let us find the equation. Let's find the equation. You see, we got c's coordinates and we got a's coordinates. Find the equation of AC. So the equation of AC is, let's find the m of the line. Did we get the m of this line? No. The m is equal to y2 minus y1 over x2 minus x1. So that's 6 over 3, which is equal to 2. That's the m of the line. So y minus y1 equals m into x minus x1. So we can use any pair of coordinates. Y minus 5 is equal to 2 into x minus 1. Y minus 5 equals 2x minus 2. Y equals 2x minus 2 plus 5 is 3. So now that 3 value is that. The c value is your y-intercept. And that is the distance of OF. Therefore, OF equals 3. That means from here, that's O, that's F, that's 3. Then you calculated EC, that's EC. EC is how much? We read it off from here. How much was that? 5. So half of the sum of the parallel sides, your perpendicular height, how much is OE? From here to here is the x value, from there to there is 1. So let's go. Area equals half of the sum of the parallel sides times your perpendicular height. Area equals 3 plus 5 is 8. 8 divided by 2 is 4. 4 times 1 is 4 units square. And there we go. We are done. That's the area of CEOF. Please learn the area of a trapezium. It's asked a lot. Either this year or next year, there's a big chance that the area of a trapezium is asked. So what's it? Half times the sum of the parallel sides multiplied by your perpendicular height. Okay. I want you to find me the equation. Okay. Find an equation of a line parallel to AB passing through C. Right, let's go. I'm adding another question on. Right, those of you who have taken this one down, you can start with the next one. Find the equation of a line parallel to AB passing through C. Go for it. Come, guys. The minute they use the word parallel, we know we're working with gradients, right? Okay, here we go. Here's our answer. That's the question. Here's our answer. So firstly, we're going to find the m of AB. The m of AB is y2 minus y1 over x2 minus x1. So that would be 5 over minus 1, which is equal to minus 5. Therefore, the m of your parallel line will also equal to minus 5, because the two gradients are the same. Therefore, the equation of your new line is y minus y1 equals m into x minus x1. So y, let's call it x1, y1. Y minus 5 equals m minus 5 into x minus 1. Y minus 5 equals minus 5x plus 5. Y equals, take this on the other side, 5 plus 5 is 10 minus 5x plus 10. And there we go. That's the equation of a line parallel to AB passing through C. That means it would look something like that. That's the equation of that line. That's what the line would look like. It's parallel to AB passing through point C. Right. Now I'm going to give you one more question. We're going to wrap up with analytics, and then we're going to start with trigs. I just want to see how sharp are you. Right. Let's see if you guys are, let's see who can do this. Right. So I give you this. I give you that. I give you this. I give you that. And I give you that. Right? Right. Pay attention. I call this angle theta. This is A, that's B, that's C. A's coordinates 4 and 20. B's coordinates minus 10 and 2. C's coordinates 12 and minus 6. Right. Find angle theta. Find angle theta for 6 marks. Find angle theta for 6 marks. Why is it 6? Because it's not leaning, it's not against your x-axis. Right, I'm going to give you 2 minutes. How's our onliners doing? Okay, let's go, let's go, let's go, let's go. All right. Guys, what we can do is we can shift the x-axis right up to that point there and split the angle up. Watch here. I can call the stop piece angle theta 1. I can call the bottom piece angle theta 2. The whole of angle theta is if I add these two, theta 1 plus theta 2. Now, remember, this line is going to go like that, and then this line here at the bottom is going to continue up there, right? So the gradient here at the bottom is going to be the same as the gradient here on top. So what you can do here, this is one way of doing it. That is one way of doing it. Let me show you a different way of doing it. Right, I just want to do it here on the side. Let me show you. So you've got this. You got it looking like that, and like that, right? So that's A, 4 and 20. This is C, 12 and minus 6. This is B, minus 10 and 2. That's angle theta. What you can do, guys, if you don't want to do that, what you can do, extend this line to the axis, calculate this angle here, call that theta 1. Find this angle here. This angle is angle theta 2. Then we know that this is a triangle. And we know that exterior angle is equal to the sum of the interior opposite angles. Yes or no? Right. So let's calculate what this angle theta 1 is. So if I do this, so I'm going to say tan of angle theta 1 is equal to the gradient of line AB. Ah, what a guy. Yeah. What? Thanks. Right. So tan of angle theta 1 is equal to y2 minus y1 over x2 minus x1. So 20 minus 2 is 18 over 14. So theta 1 equals shift 10. Go to your calculator, shift 10. We're going to go for break now. 18 over 14, 52,12, 52,1 degrees. Right, so this angle here is 52,1. Now, tan of angle theta 2 equals the M of line BC. So tan of angle theta 2 is equal to y2 minus y1 over x2 minus x1. Tan of angle theta 2 equals 8 over minus 22. Theta 2 equals shift 10. Shift 10, 8 over minus 22. I get minus 19,98 or minus 20 degrees. So that means this here is 160. 180 minus 20 is 160. That means theta 2 is, therefore, angle theta 2 equals 20 degrees. There we go. Therefore, angle theta will equal to theta 1 plus theta 2. Why? Exterior angle of a triangle. Write it down. Exterior angle of triangle equal to sum of the interior opposite angle. So is equal to 1 plus theta 2 is 20. What's your final answer for theta? 72,1 degrees. Right, guys? Learn this. Learn when theta is placed at different places in a triangle. If theta is placed at different places in a triangle, Right. Yes. Which? Huh? Okay, you'll show me during break. Okay. Yeah. Okay. Come, let's see. Yay, give him a nice round of applause there. Owens our face here. Owens our face. Let's see what you did.
So my handwriting is not that good, but you take the gradient at M1 minus by M2 plus 1.
1 plus M1 times M2.
Yes, then you're going to get this answer.
Where you got it from?
You use it in class.
Are you serious?
Yes.
Which school?
Chris Wayne.
Okay. Nice, 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 nice. Well done. No problem. Well done. Give him a nice round of applause there. Excellent. Excellent. Okay. Let's go into trigonometry. Let's go into tricks just to give you an overview. Put the heading trigonometry tricks. Right. The first thing, you will be given a diagram. Then you have trig substitution. Then you got reduction. Then you're going to get an identity. You're going to get one of each of this. Then you're going to get an identity. Then you're going to get a general solution. Right. That's going to be your trigs. Then you're going to have a trig graph. So your analytics being 30 marks, this year being another, I would say about 40, 25 marks on trigs, another 15 marks on trig graphs, and maybe another 30 marks on Euclidean. And that's going to give you your 100 marks for your Jude paper 1. Paper 2, sorry. About 25 marks. So let's see here, mark allocation. If you had a diagram, would maybe be about 6 to 8 marks. Trig substitution, maybe another 6 marks. A reduction, 5 marks. An identity, maybe 4 to 5 marks. Maybe 6. Reduction can go up to 6 marks. Identity, maybe 5 to 6 marks. General solution, 6 marks. 6, 12, 18, 24, 30. Maybe graphs another 10 marks. That's going to give you 40 marks. And then you add your analytics, which we said about 30 marks. So 30 and 40 is 70. Your Euclidean, going to be another 30 marks. And that's going to give you your 100. Okay. It's 10 past 10. We got another about 15 minutes to go. Let's just start off with the diagram and some substitution, and then we go for break. Then we have our breakfast comfort break. Right, let's go. So you've all got that. Let's start off with the diagram. Let's start off with a diagram. I give you a diagram. Take it down. And let's say I give you that. I call this angle theta. We call this point P. I tell you that's minus 3 and 7. That's 0. That's X. That's Y. Shh. Question number 1. Find sine theta, no calculator. Find sine theta, no calculator. Right, number 2. Find cos 180 plus theta. Number 3, find 2 tan squared theta over cos theta. Number 4, find sine squared theta plus cos squared theta. And number 5, find theta. What's the first thing we do here, guys? We drop our perpendicular, we make a triangle against your x-axis. X value, y value. So that's 7 and that's minus 3. We now find OP, the hypotenuse. So OP squared is equal to 7 squared plus negative 3 squared. OP squared equals 49 plus 9. OP squared equals 58. OP equals the square root of 58. Square root 58, boom, we leave it as square root 58. Do not use decimals. Leave it in third form. Right. Now we start answering the questions. Sine theta. We know SOHCAHTOA. Sine, opposite over hypotenuse. Opposite, that's angle theta, opposite over hypotenuse. 7 over root 58. Yes or no, guys? Right. Number 2. Never heard of SOHCAHTOA? Yo. SOHCAHTOA. Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. Oh, hell, another hour of algebra. And then you just put sine, cos, and tan. Right. Cos 180 plus theta. Now here comes your rules of reduction, guys. Cos 180, you know the name stays. You know 90 and 270 name changes. So cos 180 would be cos theta. 180 plus is in your third quadrant. What is cos in your third quadrant? Positive or negative? Negative. So now minus cos theta is adjacent over hypotenuse. So that's minus adjacent over hypotenuse minus 3 over root 58. So your answer is 3 over root 58. Right. Let's do number 3, 4, 5, and we go for break. So we're done with number 1, we're done with number 2. Ah, come on, do the thing, man. It's easy. Substitute, man. Right. Number 3, 2 tan squared theta over cos theta. Now, I can make that. I just want to see. So that's 2. Tan theta is 7 over minus 3 squared over cos theta is minus 3 over root 58. Now they say no calculator, so they want to see you do all the calculations. So now what would that be? That would be 2 into 7 squared is 49 over negative squared is positive, 3 squared is 9, divided by, that's divided by minus 3 over root 58. Okay. Now we need to show our calculations here. The algebra. So this is equal to 2 times 49 is 98 over 9 times root 58 over minus 3. So 98 times root 58 over positive times negative is a negative. 9 times 3 is 27. Can that be simplified? Now you can 98 root 58 over 27. Nah, that's your final answer. You can't simplify that any further. Last two. You know from your identity what is sine squared plus cos squared? 1. But now you have to show it. You have to show it. You can't just put 1. Right, let's do sine squared plus cos squared. Sine squared theta plus cos squared theta is equal to sine theta is 7 over root 58 squared plus cos squared theta is minus 3 over root 58 squared. 7 squared, 49 over 58 plus 9 over 58. You're now going to get 58 over 58, which is equal to your identity, 1. That's how they get 1. Anytime sine squared of an angle plus cos squared of that same angle will always give you 1. Find theta, very easy. Find theta, we can say sine theta is equal to 7 over root 58. So theta is equal to, let's go to our calculator, shift sine fraction 7 over root 58. Boom. We get 66,8. We can leave it there. 66,8 degrees. If they told you theta was here outside, then you'd have to say 180 minus 66, and that would have given you that angle there. Because theta is already given to you here in your triangle there, 66,8. Okay, guys. It's 10:20. We go now for break. I'm going to give you 30 minutes. I will see you guys back in here at 10:30. 50. Right, so guys, hope you guys enjoyed first session. Give yourselves a nice round of applause. I'll see you guys at 10:50 a.m. Enjoy your break. Yeah. Half the sum of the parallel sides multiplied by your perpendicular height. So you must say, so if you got a trapezium, you take that length and you add it, you say half of the sum of them times your perpendicular height. So if this is 10 and that is 30 and that is 5, so area is equal to half of 10 plus 30. Right, let's take time for fun. Maths is fun. Welcome onliners, welcome back. I hope you enjoyed your break. If you really pay attention to us today and you lock in, I guarantee you 90% in your exam. 90 plus. Guaranteed. Just pay attention. That's all I want. Pay attention. Give me your full attention, lock in, and let's cook math. Right. If cos 23 is equal to the square root of 1 minus g squared. Now, thank you. Find the following in terms of g. Right, question number 1, sine 23. Question number 2, tan 113. Question number 3, sine minus 653. That's a 5. Okay, here we go. Thank you. Learners who are walking in, come in quietly. Take your seats. Let's go. Now, this is a very important style of a question. They can give you any angle, sine, cos, tan. They can say 1 minus m, 1 minus p, p squared, m, a, b. Doesn't make a difference. Find the following in terms of g or p or m. Pay attention. Pay attention. The first thing that we do, guys, in our answer, before we even start this, we make this over 1. So we use this method. Guys, I'm showing you a trick. We use what I call, this is a mental procedure called scrap. S, standard form and Sohcahtoa. C, draw your Cartesian plane. R, look at your restriction if you have a restriction. A is just for and P is for Pythagoras to complete. So whenever you need to draw a diagram, just think scrap. It's a mental process. Right. Sohcahtoa for cos, adjacent over hypotenuse. Yes or no? Right, so there's S. What did I say? Second thing, Cartesian plane. Let's draw a Cartesian plane. Is there a restriction given in this case? No. A is just for and. Now, let's draw. If no restriction is given, like in this case, no restriction is given in this case, we just draw it in our first quadrant. That's 23. Adjacent over hypotenuse, 1 minus g squared over 1. How do I complete the diagram? Using what? Using who? Pythagoras. Guys, are you following me, grade 11s? Right, let's go. So we want the y value there. So I'm going to say 1 squared equals square root 1 minus g squared plus y squared. 1, that's all squared, is equal to 1 minus g squared, that and that will cancel out, plus y squared. 1 minus 1 plus g squared equals y squared. Y squared equals 1 minus 1 is 0. G squared, y squared equals g squared. y equals the square root of g squared, y equals g. So this y is g. Yes or no, guys? What do you mean? I'm using Pythagoras, duh. The hell? How can you not know how to do Pythagoras in grade 11? Seriously? Right, so we use Pythagoras. Now we use Sokotoa to answer the questions. Now, why are you guys talking? Hey! Come on. Right, sine 23. Let's do number 1, sine 23. Sine 23. Just use Sokotoa. Opposite over hypotenuse. Right, so your opposite over hypotenuse is g over 1. Your answer is g. Agreed? Number 2. Tan 113. Now we need, what is the relationship between 113 and the reference angle that they gave? Pay attention. Pay attention. So tan 113 is going to be tan 90 plus 23. Because we need a 23 degrees in there. Now tan 90 plus 23. We can't use co-functions. So what we're going to do now, this is sine 90 plus 23 over cos 90 plus 23. Tan is sine over cos, yes or no? Right. Sine 90, the name will change to cos 23. 90 plus is in your second quadrant. Sine in your second quadrant is positive. You look at the original, don't look at the changed one. Cos 90 will change to sine 23. 90 plus is in my second quadrant. Cos in my second quadrant is negative. Cos 23 is adjacent over hypotenuse, which is square root 1 minus g squared over minus. What is sine 23? We just found out what was sine 23 on the top. G. Now you can leave it like this, but the better way is to say positive divide. Never leave a negative in your denominator. So positive divide by negative is minus square root 1 minus g squared over g. That's the better way of answering it. You could answer it like this, you'll get it right, but it's not mathematically appropriate to leave a negative sign in your denominator. Are you guys with me, guys? Right, let's do the last one. Sine minus, now here's a negative angle. What do we know about our rules of negative angles? Sine of a negative angle is minus sine. Tan of a negative angle is minus tan. But cos of a negative angle is what? Positive. Cos of a negative angle is positive. Remember that. I'm going to write that rule down here on the side for you. I'm going to write that rule on the side for you. So just put these rules down for negative angles. You need to, till grade 12. Sine of a negative angle is minus sine of that angle, to remove the brackets. Tan of a negative angle is minus tan of that angle. Cos of a negative angle is positive cos of that angle. The negative falls away. Why? Why? Because 0 plus cos is positive. Negative angle is 0 minus is in your fourth quadrant. Cos is positive there as well. So a negative angle doesn't exist for cos. Here we go. Let's go back to this problem. Shh. sine minus 653. This is equal to minus sine 653. Now, minus sine, how many rotations are we going to take out here? So if I took 653 minus 360, I get 293. If I minus 360 from here, I get 293. Now there comes my 23 degrees. 270 plus 23. So sine 270, the name will change to cos 23. Remember, 270 and 90 name changes. 180 and 360 name stays. Do you remember that? Some of you, anything I ask you, just say no. It's like you've never been to school. Right, sine 270 changes to cos 23. 270 plus is in your fourth quadrant. Sine in your fourth quadrant is negative. Negative times that negative is a positive. And cos 23 is the square root of 1 minus g squared. And there's your final answer. Let's get into reduction. Let's get into reduction. Then we're going into identities. Then we're going into general solution. I told you guys are going to love today. If you learn what I told you now as templates, you memorize it, you'll get them all right. Okay. Now comes laws of reduction. Right. Reduction laws. Guys, there are 5 laws that you need to remember from now till grade 12. If you memorize these reduction laws, you'll never have a problem in math. I'm going to summarize everything for you on this one screen. So whatever notes you get from your textbooks, from school, from anywhere else, use it as toilet paper, wipe your backsides with it. This is all you need to know. What I'm about to put on the screen is the only tools you know to master reduction. The first one that we all know, what's going on here? Right. The first law of reduction is the name change or name stay, the Cartesian, right? We know that 90 plus 90 minus 270 plus 270 minus the vertical line on your Cartesian plane, the name changes to co-function. Sine will change to cos or cos will change to sine. We know, and we're going to avoid using this. I'm not saying never use it. If it's in the problem, you got to use it, but avoid. We know 180 plus 180 minus or 360 minus the horizontal line we use. Why? The name stays. So if it's sine, it will stay sine. If it's cos, it will remain cos. Second one is what we call our negative angles, which we just did now. Sine of a negative angle is minus sine of that angle. Tan of a negative angle is equal to minus tan of that angle. What did I tell you now? What about cos? Cos of a negative angle is what? This is equal to positive cos of that angle. Number 3, the anti-clockwise angle. Now check this one out. You're going to come across it. So if I told you sine x minus 180. Now I'm going to show you a Kwai method of doing it. You can use it till grade 12. A very, very different method. Now normally you'll have 180 minus x. If you had x plus 180, that's not the anti-clockwise angle, but x minus 180. That's called the anti-clockwise angle. So watch here what we do. Put your pens down. Onliners, how are we doing? Onliners, how are we doing? Right. Sine 180 will remain sine x, right? You all know that. Now we need to determine whether it's positive or negative. So watch what we do. I call it the dial method. Watch here. Watch here. Sine. In which quadrant does sine live? First, second, third, or fourth? Good. And we're going to move 180 degrees anti-clockwise. So from here to here is 90. From there to there is 180. So we land here. So we start here and we land here. What is sine in this quadrant? What is sine in this quadrant? And there's your final answer. You can just draw that to the anti-clockwise. Ask yourself, what is that trig function in that quadrant? And then put the sign positive or negative. So that's your anti-clockwise. The next set of laws is your square angles or an angle squared. Like sine squared 270 minus x. Now sine 270, now anything squared is always positive. Here you don't need to check quadrant. Sine 270 will change to cos squared x. Do I need to check whether it's positive or negative? No. Why? It's squared. Anything squared is always correct. We got one more set of laws. Then we're ready for battle. Then I'm throwing you into the two questions from the past paper. We're going to get full marks for it. One more set of laws. One more set of laws. And that's an angle greater than 360, like what we had before. So for an angle greater than 360, we always subtract 360 from the angle. So if we had to reduce cos 480, for example, how would we reduce cos 480? Let's all do it together. Let's all do it together. This is equal to cos 480 minus 360 is how much? 120. Now we reduce. This is cos. Well, I say 90 plus or 180 minus? I said avoid 90 and 270. So what am I going to say? 180 minus how much to give me 120? 60. Yes or no? So cos 180 is what? Cos 60. The quadrant falls away. 180 minus is in my second quadrant. Cos in my second quadrant is negative. Minus cos 60 is sine 30, which is a half. Special angle. Right? So now we know our 5 rules. That's the only 5 rules you need to know from now till the end of grade 12 in terms of reduction. Next year you'll be taught the compound and double angle rules, but let's leave that for another day. For another year. For next year. Right, here we go. Now the first one is worth 8 marks. Here we go. Right, so these are the laws, right? We're going to apply the laws to this next scenario for 8 marks. Cos 390, take it down. Cos 390 over cos minus 30 minus tan 360 minus x times cos 180 plus x times cos x minus 90. Oh, I love this problem. You know why? It tests us on all our laws besides the square one. So here's an angle greater than 360. There's cos of a negative angle. There's our name keep. There's our name keep. There's our anti-clockwise law. The only thing that's not asked in this question is a square one. Other than that, all from the 5 laws, 4 laws are tested in here. Simplify for 8 marks. Right, put it down. Put down your pens after you've taken it. Let's all do it together, step by step. And guys, please learn this, pick up this habit. When you're writing your fractions, write it over 2 lines. Numerator on 1 line, denominator on the second. Don't try and squeeze it in 1 line. Right, let's do it together. Cos 390 is cos 360 plus 30. Over. Cos of a negative angle is, the negative will fall away. It's cos 30. Yes or no? Can you see how we're going to get our answer like a hot knife through butter? If you just know your laws, everything will just work itself out. Right, minus tan 360 minus x. Tan 360, name will stay tan x. 360 minus is in my 4th quadrant. Tan in my 4th quadrant is negative. Negative times this negative will make it a positive. Times cos 180 will remain cos x. 180 plus is in my 3rd quadrant. Cos in my 3rd quadrant is negative. Negative times this positive makes it a negative again. Times cos 90. The name changes to sin x. Cos lives in this quadrant. We're moving 90 degrees anti-clockwise, so from there to there. What is cos in the 1st quadrant? Positive. So we leave it. Beautiful. How nice. We know we're going to get full marks here. We know we're going to get our full 8 marks here. Guaranteed. We don't think we're right. We know we're right. Right, here goes. Let's go. Cos 360 is cos 30. 360 plus is in your 1st quadrant. Cos is positive. Over cos 30 minus tan x is sin x over cos x. You always convert tan to sin over cos. Times cos x over 1 times sin x over 1. Let's have fun. Cos 30, 1 minus cos x will cancel. Sin times sin is what? Sin squared. Ting, 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 ting. 1 minus sin squared. Your identity is what? Cos squared x. Game over. You got yourself 8 marks like a boss. Right. Khalid, we sharp.
Just a small announcement, important one. There's a girl who lost her calculator. Please, please, if you picked it up, I know you're waiting for me to say that I've got something for you. I don't. But if you did pick up the calculator, please bring it forward. E-blue. E-blue. Because ndiyabona ubanchong by e-blue nzawubethwa. So if uthole calculator e-blue, cele ayo ayike susigezeni.
Right, let's do another one. Now this one, the next one comes out of 2023 Gauteng November paper, right? The next one. Are you still writing? All right, I know some of you are quite fast, so you'll probably want to start with the next one. I don't want to waste your time. You can already start with the next one, simplify. Cos 90 minus alpha, sine minus alpha minus 540, all over 10,225 plus sine alpha times sine 180 plus alpha. Right. How many marks for this? 6 marks. What did we say? This was KZN June 2024 was that first one, eh? Yeah. Do this one, start it. Okay, let's do this. Cos 90 will change to sine alpha times sine. Ooh, now we got a story here. Now we have a story there. That's a story. What are we going to do there? Now watch. Let's do this. Make it a negative angle in the bracket. So that's minus into 540 plus alpha. Don't take the negative out. Do it like this. Over. 10 to 5 will be 10, 180 plus 45. Plus sine alpha. Times sine 180 will remain sine alpha. 180 plus is in my third quadrant. Sine in my third quadrant is negative. Right, now let's see, what are we going to do there? That's the catch of this problem. So now we're going to go sine alpha times sine of a negative angle is minus sine. Because we're multiplying, I'm just taking the minus right to the front. 540 plus alpha all over 10, 180 will remain 10, 45. 180 plus is in my third quadrant, 10 is positive, minus sine times sine is sine squared alpha. Let's go to the side, minus sine alpha. What did I say? If you got 540, we minus 360. So it's the same as saying sine 180 plus alpha all over 1045 is 1 minus sine squared alpha. Pay attention, it's coming, the answer is coming. So there we go, minus sine alpha times sine 180 is sine alpha, 180 plus is in my third quadrant, sine in my third quadrant is negative. Negative times this negative here in the front will make it a positive again. Be careful. There's a double negative here. It's negative because it was a negative angle, and because it's 180 plus, it's negative. So negative times that negative outside makes it a over 1 minus sine squared alpha. I'm going to move over to the side. I don't have space. Sine times sine is sine squared alpha over 1 minus sine squared is your identity is what? Cos squared alpha. Come on. Sine squared over cos squared is what? 10 squared alpha. That's your final answer. We simplified it to a single trig ratio. I told you if you follow my rules, you'll get it right every time. Right? Naman. Learn, memorize, master, item for item, and don't stuff up your signs. That's all. Can you see how slow I'm doing? I'm doing it so thoroughly. This is the same way I would answer it in the exam. I'll take each part on its own and make sure that we sort it out proper. No rush, but get it right first time. And when you get an answer like this, sine over cos, you don't think you're right. You already know you're right. Right, let's give you one reduction in terms of angles. So some of you have taken this one down already. You can start taking the next one down. Sine 120. This is going to be easy. Sine 120. Tan 330 degrees over cos 240. Come on, this is gem. Marks for gem. 5 marks. Marks for gem. Straightforward reduction. Special angles. Special angles. And use your quadrants. Come guys, get it right. Get it right. Are you ready? Who's done? Yo, guys, you guys need to be machines at this. A problem like this, if you're doing it 30 seconds, 35 seconds, tops. Otherwise, it means you don't know your work. I think between yesterday and today, I think many of you have realized how much you didn't study in math this year. How much attention you didn't give to math this year. How much you thought you could wing it just the night before your exam. It ain't going to happen. Maths, you got to be consistent the entire year. If you think even 1 week before your exam, you're going to start mastering and practicing, you got another thing coming. Yeah, you think you're going to do smash and grab. Let's go. Sine 120 is sine 180 minus 60. Don't use 90 plus 30. Tan 330 is 360 minus 30. All over 180 plus 60. How many of you got that step right? Well done. Now let's go. Sine 180 will be sine 60. 180 minus is in my second quadrant. Sine is positive. Tan 360 will remain tan 30. 360 minus is in my fourth quadrant. What is tan in my fourth quadrant? Negative. I'm moving this negative from here to the front. It's not that sine is minus. It's just because these two are multiplied, I'm bringing it to the front. But not to confuse you, let me rather just put this negative here. Just now you'll say, but why did I make sine 60 negative? Over. What the hell? Cos 180 is how much? Cos 60. 180 plus is in your third quadrant. Cos in your third quadrant is? Now be careful. Cos you're multiplying. You're multiplying. So I can cancel that negative and that negative. Negative divided by negative is a? Right. Now, sine 60 is square root 3 over 2. Tan 30 is root 3 over 3 or 1 over root 3. Same thing. Cos 60 is sine 30, which is a half. Root 3 times root 3 is 3. 2 times 3 is 6 over a half. 3 over 6 is a half. Divided by a half. Half divided by half is 1. Guys, what's happening there at the back? Please, man. Right. I'm going to do, now we're going into identities, proving left-hand side equal to right-hand side. We're going to do 3 examples. I'm going to do level 1, level 2, level 3. One of each. Right. So for the cast diagram, what did I tell you when we had to draw it? We use scrap. SOHCAHTOA, Cartesian plane, restriction, and Pythagoras. Don't forget that. For identities, listen to me. I got another acronym for you to remember how to do the process of doing it. It's very nice. You'll always get it right. Watch. Right. I want you to remember for identities. And God willing, I'll be seeing. Remember, I told you guys yesterday, for those of you who weren't here yesterday, I'm going to be seeing you in September again. We're coming for the prelim run for grade 12s. And I think we'll be doing the grade 11 one again here at Portland's in August, late August, before your September. Then I come again in October before your finals. So I'm going to see you 2 more times this year with past paper. Shh. And next year, hopefully, I'll see you 4 times. But now hear me out. The reason I'm showing you these systems, so that we'll be using these systems continuously until the end of next year. Learners who have used my systems, who have logged in, they scored 98 plus. Rory Sang from Kailicha got 100 in matric. Total. Khalid, where was Rory Sang from? Kaya. Limpopo, sorry. Rory Sang was from Limpopo. 100%. And he used our systems in his matric exam. He was also like you sitting in the workshop. He was like you sitting in his workshop. He got 100. What's he doing? He's doing actuarial science. He's mastering. He's now taken mathematics as his career. And as an actuary, your starting salary is more than 150,000 rand per month.
Starting.
You can earn up to 500,000 rand to 700 to 1 million rand a month.
But Mr. Kouta, here's the point. Jada from
Yeah.
Strandfontein High School, grade 11 last year, she scored well in her final exam. She was one of the winners of our competition.
Yes.
She's in grade 12 this year.
Jada from Strandfontein High was also part of the grade 11 program, sitting like you.
What
She was the top winner in our competition, top result for grade 11 from Strandfontein. This year she's acing, and we hope, let's all pray for her. Let's all give her a nice round of applause as well. And let's support her and all of you that will be now gunning for your 100%.
And she's been provisionally accepted for actuarial science.
And she's also been provisionally accepted at UCT for actuarial science.
Show me the money. It's about the money.
Let's go. Guys, it's not impossible. Don't blame anybody for any of your situation that you're in. The choice is yours. Your attitude determines your altitude. Right, pay attention. Shh. Pay attention. Thank you. Identities. Here's the process. Ali. I know you're saying, what the hell? Ali does identities. Who does identities? Right. What does AL stand for? Step number 1. Do the algebra. L for algebra. I. Step number 2. Look for your identity. The problem will work itself out. Right. Watch here. So here the question is going to say prove. Prove that sine x plus cos x all squared is equal to 1 plus 2 sine x cos x. For 3 marks. Let's start on the left-hand side. Right. Shh. What did I say? Who does identities? So what's step number 1? Now in algebra, we're squaring a binomial. You remember we squared a binomial yesterday? I showed you the shortcut. Square the first term, what do I get? Sine squared x. Yes or no? Square the second term, what do I get? Cos squared x. I showed you yesterday, how do we get the middle term? You multiply the 2 and then you times it by. So it's plus 2 sine x times cos x is sine x cos x. Yes or no? That's the algebra. Right. Now what's the second step? Identity. Look for your identity in here. Sine squared plus cos squared is how much? 1 plus 2 sine x cos x. And isn't that my right-hand side? Here's your identity. Sine squared plus cos squared is 1. Therefore, left-hand side is equal to right-hand side. That what? What's happening? Okay. Oh, yeah. Yeah. MashaAllah. Tariq. All right. So this is example number 1. Shh, learn it. Let's go example number 2. Just remember, who does identities? Ali. Ali does identities. Step number 1, algebra. Step number 2, look for your identity. Right, for those of you who did this one, you can take the next one down. Prove that 1 over 1 plus sine x plus 1 over 1 minus sine x is equal to 2 over cos squared x. 5 marks. We start on the left-hand side, and we have to make the left-hand side look like the right-hand side, and we use Ali to Dala. Ali is our weapon of choice. Ali is our weapon of choice. Right, put your pens down. Let's all do it together. Left-hand side. Right, in algebra, I am adding 2 fractions. What must I do? In algebra, when you add 2 fractions, what must you do? Lowest common? Right, so let's go. LCD, left-hand side. It's 1 plus sine x into 1 minus sine x. Yes or no? Right. So 1 plus and 1 plus, we're dividing, so it will cancel. I'm left with 1 minus. 1 minus sine x times 1 is 1 minus sine x plus 1 minus will cancel. What am I left with? 1 plus sine x times 1, 1 plus sine x. I'm not yet done with my algebra. That's LCD. Right, let's simplify what we can. Minus sine x plus sine x, 0. Grade 1s, 1 plus 1 is how much? 2 over. My denominator is the difference of 2 squares. 1 times 1 is? Positive times negative is? Sine times sine is? Right, I'm done with my algebra. What must I do? Is there an identity staring at you in the face? So 2 over, what's 1 minus sine squared? And isn't that my right-hand side? Game over. Right. Okay, are you ready now for Shark Tank? Are you ready to swim with the sharks? All right, the next one's a bit rough. The next one is from the past paper. Okay, so maybe there's the water. You know this guy. Do you know this guy? Do you know this guy? You know this guy. You know this guy. Yeah. Say hello to my new friend, Mr. Jaws. Hello, Jaws. Jaws is about to show you some nice things now. Prove that cos x times tan squared x over 1 over cos x plus 1 plus cos x equal 1. 7 marks. Yeah, Jaws is hungry. Jaws is hungry. Right. Dala, why are you waiting for me? Go fight him. Take the harpoon. Let's see how you drown Jaws. Who's getting eaten? It's you or Jaws? Or Jaws is getting eaten. You're making sushi out of Jaws. Okay. Huh. What's the time? No, it's still early.
No, they want the time from you. You will be ready at
Hmm. Nice one. Convert the yeah, there's a lot of algebra involved here. A lot of algebra. Your big work is the algebra. Your big work is the algebra, not even the trigonometry. Are you winning? Some of you haven't even started. You're waiting for me to do it. Yes. It's 12 o'clock. We got 30 minutes before lunch. Your amazing burgers will come. World-class, world-renowned burgers. Finger-licking good. Mouth-watering, juicy. Long neck burgers. I know last night you guys were dreaming about today's burgers that were about to come. I was. Right. Are you ready for Shark Tank? You want me to dial it for you? Okay, here we go. Left hand side, left hand side, left hand side. Assalamu alaikum. Salam. Are you Sheikh? Come through. Assalamu alaikum. Salam, how are you? Alhamdulillah.
Ladies and gentlemen, put your hands together for Sheikh Ibrahim Gabriel. This is Sheikh Ibrahim Gabriel. He's a very important leader of the community from Masjidul Rabi, from the Muslim Judicial Council, as well as a trustee on the Awqaf South Africa board. We're going to give Sheikh Gabriel a few words of motivation for our future generation. Assalamu alaikum, Sheikh. We're so pleased that you are here.
Honorable learners, good afternoon. It's a great honor for me to be here. I am the Imam or the Umfundis of Portland's for 38 years. The mosque opposite Mondale High School. Have you seen that mosque? So I'm the Imam or the priest there for 38 years. So I'm also the unofficial mayor of the Republic of Portland. So as the unofficial mayor of Portland, I want to welcome you to the Republic of Portland. And we wish you well for your studies. And I want to tell you, when I was at school, that education was called the gutter education because of the color of our skins. That is the reason why we are also in Mitchell's Plain. I was born in Claremont, but because of the color of my skin, we were thrown here into Mitchell's Plain. We were forcibly removed. We didn't get the same education and same level of education as the white people. The white people still have the privileges. One of the sickness of the world is the white supremacy. That is why Donald Trump went to fetch the president of Venezuela. Imagine he kidnapped a president of another country. But anyway, that is not my topic. My topic and my motivation is for you here to work hard so that you not only going to earn a lot of money one day, but that you're going to make a difference in this world. We are all here to make a difference. I traveled a lot. So one day I was on Nairobi airport in Kenya. So I was walking around, and whenever I travel, I like to buy a book. So I saw the book, the bigger picture. And the writer of the book says, when I was in grade 4 or grade 5 at school in the United States of America, and he's a Negro boy. His name is Benjamin. Black boy from America. He says one day his teacher said, his mother said to him, "You, Benjamin, you and your brother Curtis, no more TV programs, and I want the two of you to go to the public library and you must read 2 books every week, and every week you must give me a report." And so one day he was sitting in the class, and Benjamin was also known as the dumbest in the whole school. The whole school knew that he is the dumbest in the whole school. So after reading and reading, so one day the teacher came into the class and kept up a black rock. And the teacher asked learners, "Who can tell me what's the name of this rock?" And Benjamin looked around and nobody raised their hand. And he thought, maybe today is my day. And he raised his hand And the other learners thought, ooh, this is going to be a stupid answer because he's most the dumbest in the whole school. And the teacher said, Benjamin, go for it. And he said, the name of that rock is Obsidian. And there was silence in the class. And the teacher said, Benjamin, you're right. And he thought to himself, this is because of the advice of my mother. I must read and I must read. And he started to read biology, history, all the subjects. He said in grade 7, the same children that called him the most dumbest came to him and asked him, Benjamin, can you explain this in mathematics and science? He said, you couldn't brag, but he said to them, first sit at the feet of your master and your master will explain to you. Now, this is now the end of the story. Today, and Benjamin, his surname is Carson. Benjamin is still alive and he's not an ordinary medical doctor. He's a neurosurgeon. Yeah. And you can look up his name, Benjamin Carson. And so I just want to conclude to say, now look at the advice of the mother. The mother said, you're only allowed to look at 2 programs for the whole week on TV. That time there was no cell phones. You can only look at 2 programs for the whole week, but you must read 2 books every week. Now I want to say to you today, the biggest challenge to all of us, including you as learners, is this phone. If you're not going to discipline yourself, you're not going to become civil engineers and medical doctors and neurosurgeons. So you will have to discipline yourself. And I'm so happy that you're eager to have this maths program. As you've heard, I'm also a trustee of Awqaf South Africa. And we are doing this only for your concern and love for you. And that God Almighty grant you all to be great leaders one day. Shukran,
Ameen.
thank you.
Ameen, 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 ameen. Thank you, Sheikh. Jazakallah. Shukran so much. Brilliant words of advice, words of wisdom from Sheikh Ibrahim Gabriel.
So, God willing, Awqaf, in association with the department, the schools, as well as some of the Islamic and other institutions, we will be working jointly to contribute to providing quality education here in South Africa. This is all about your future and your success. So,
Do you guys want us back this year? Do you want us before finals again? And next year for grade 12, before prelims and finals?
yes.
Beautiful. Are you guys going to come Saturday and Sunday again? Give yourselves a nice round of applause. Well done. Well done, well done, well done, well done. Love the energy. Shukran so much, Sheikh. Alhamdulillah. Alhamdulillah. Here we go, and back to the grind. Back to the grind. Let's go, let's go, let's go. Right, back to math. Back to math. Right. Right. Here's when they say, like you people say here in Cape Town, die kak gaan spat. Hier rugidang. No rugidang. Die poppe gaan nou dans. Right. Cos X. Cos X. Tan squared X. Sine squared X over cos squared X. Okay. Over cos squared X. Right, pay attention. That's over 1. What I'm going to do, I'm going to say divided by my denominator. I'm moving it to the side because I don't want to work with a fraction over a fraction. You can move it to the side. Plus 1 over 1. Plus, don't forget the plus cos x at the back. Pay attention. Right. We're not yet done. Don't write. Don't write. Let's do it together. We're multiplying here. Right, so cos x and the 1 cos x from cos squared x will cancel out. So I'm left with sine squared x over cos x. That one is gone. Divided by, I'm going to do the LCD here. What's your LCD here? Cos x. Cos into cos once, 1 times 1 is 1. Plus 1 into cos, cos times 1 is cos. Plus cos x over 1. Not yet done. Sine squared x over cos x. Now that you got it as one fraction, we can multiply. So multiply. Swap this over. Cos x, tip and times, over 1 plus cos x plus cos x over 1. Let's sort here out first. Because multiplication, BODMAS, we do multiplication first. Cos x and cos x will cancel out. Not yet done. Let's, oh gosh, no. Let's go here. I'm moving over here to the side. Pay attention. Pay attention. This is normal algebra. Sine squared x times 1 is what? Sine squared x over 1 times 1 plus cos x is 1 plus cos x plus cos x over 1. Right, we're not yet done. Let's add the two. LCD again. LCD is 1 plus cos x. 1 plus cos x and 1 plus cos x will cancel, times sine squared x is sine squared x plus 1 into 1 plus cos x, or 1 plus cos x divided by 1 is 1 plus cos x, multiplied by cos x is cos x into 1 plus cos x. Right, wait, let's remove the brackets. Sine squared x plus cos x times 1 is cos x plus cos times cos is cos squared x all over 1 plus cos x. This is all the algebra. The algebra ends here. All this algebra, 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 algebra. Now we are done with the algebra. What do I look for? Where's your identity? Sine squared plus cos squared is how much? 1. What am I left with? Over. What's my denominator? That over that is how much? Like a boss. First time we got it right. I got no memo. I just opened up a random past paper. I took the most difficult one and said, let's all do it together. I told you yesterday, we don't look at the memo. Why? We are the memo. I had no idea how to, I didn't even know. We just said, right, let's just follow what we said. Algebra until the end. Look for your identity. Problem will work itself out. 8 marks. 8 marks. I told you, you follow my systems, you'll get 100% in your exam. How's our onliners doing it? Luklaza. We coming there next weekend. Grade 10s. We are in Luklaza, Kailicha. I'm back in Cape Town next weekend. Have you taken this one down? Come finish up. Finish up. Let's do general solution. Now here we're solving for x. Let's see which general solution did they give in this paper. Boom, 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 boom. Actually, didn't even give you a general solution for this one. Okay. Are you ready? Can I raise? Right, put the heading general solution. Right. General solution. Now, general solution, we need to solve for x or give the general solution. They'll give you a restriction. Right. I gave you scrap. I gave you Ali. I'm going to give you a new one. S, S, G, R. Stupid students get rabies. I don't know anything. I don't care what you make up with it. Just remember SSGR. That's how we do general solution. So number one, standard form. And number two, use S for shift key. G, attach your general solution. And R, look at your restriction. This is how you do when you're solving for x in trigonometry. So we know for sine, it's your answer plus k times 360, where k is an element of integers. For cos, you say plus minus your angle, your answer, plus k times 360, you attach. Shh. But for tan, it's your answer plus k times 180. Why sine and cos 360? Because one complete sine graph, sorry, I can't even cough. Imagine. Brah, they don't even allow me to cough, brah. Right, whether every sine or cos is a 360 degrees and one complete tan graph is every 180 degrees. That's why we add this. So remember S, S, G, R. Quiet. You get 3 types of general solution. In fact, you get 4 types of general solution. Quiet, quiet, quiet. You get 4 types of general solution. Single angle, compound angle, double angle, and you get a quadratic. So you get 4 types. Let's do examples of each. 1, 2, 3, 4. This is going to take us, it's 12:15, 12:30. You can go and race for your burgers. I know it was so yummy that some of you last night even went on Mr. Delivery and Uber Eats to look for it. You asked for Portland's burgers. It was nominated one of the best in SA 5 years in a row. We can talk nonsense, no? Right, let's go, let's go, let's go. Right, now you get 3 types. You get 3 types. You get the single angle, you get the compound angle, you get the double angle, and then you get, what did I say? Quadratic. So we get 4 types. This is what your single, compound, double, quadratic will look like. Your single will look like this. Sine x equals root 3. Single angle. Compound angle. Sine x plus 15 degrees is equal to root 3. Compound, plus or minus. Double. Sine 2x equal root 3. And I'll show you what a quadratic, I think you all know what a quadratic looks like.
Learners from Linda here, your teacher wants you to sign the register. So if you haven't signed the register, make sure that you go to your teacher there at the back. They want to order for you something online as well, so.
Right. Hungry lions. You know the hungry lions. Right. Right, let's do this. So we're going to follow SSGR to answer these. Let's start with the first one. Give the general solution. Right. 2 sine x minus root 5 equals 0. And x is an element of 0 to 360. That's a single angle. Question, answer. Right, pay attention. Pay attention. Let's get it into standard form first. So now we're going to say, pay attention. You follow exactly the way I do it. 2 sine x is equal to root 5. Standard form, sine x is equal to root 5 over 2. The coefficient must be 1 and you must have a fraction. That's called standard form. So there we go. We're done with standard form. Shift key on your calculator. Shift sign. So x is equal to shift sign root 5 over 2. Shift sine fraction. Root 5 over 2, boom. Oh no. We should have made it root 2. Okay, you know what? We should have made this an 8. Root 5 over 8. We should have made that an 8. Make that an 8. This one gives us a math error, obviously. So make that an 8. Make that an 8. So let's go shift sine root 5 over 8. 16,23. So there's it. We use the shift key. Now what must we do? Attach. What's my next step? SSGR. What's my next step? Attach the. What's your general solution for sine? Plus k times 360, where k is an element of integers, or now restriction 0 to 360. Where is sine positive? 1 and 2, yes or no? So this is your answer for quadrant 1. Your answer for quadrant 2, x is equal to 180 minus 16,23 plus k times 360, where k is an element of integers. So x is equal to 180 minus 16,23, 176,77, 163,8. There we go. We use SSGR and we've given a general solution. Yes, Brother Khalid in the right-hand corner, coming in at 42.3 kilograms. Featherweight, lightweight. Let's get ready to rumble. I always wanted to say that. Next one. Shh. Give the general solution. General solution. Let's say, pay attention, 2 tan x plus 10 degrees minus 8 equals 0. No restriction given. Shh. Right. So basically, we're not going to use SSGR. We'll just use SSG. There's no restriction. Right. Standard form. So this is a compound angle. Why it's compound? X plus 10. Let's get it into standard form. Therefore, 2 tan x plus 10 equals, take the minus 8 there, becomes 8. Divide by 2, divide by 2. Tan x plus 10 is equal to 8 over 2. Tan x plus 10. 8 over 2 is how much? There we go. Standard form. Shh. Now, shift key. Shift tan 4. So that's your angle. So x plus 10 is equal to shift tan 4. I think it must be 75,96. Attach your general solution plus k times for 10, 180, where k is an element of integers. X is equal to 75,96 minus 10, 65,96 plus k times 180, where k is an element of, here we go, done. Okay. So we did the single angle. I did an example now of the compound angle. Let's do a double angle, 2 times an angle. Pay attention. Pay attention. Let's do one in terms of cos, but I'll give you a double angle. Right, so let's go. I tell you cos 2x is equal to minus, okay, plus 0,1625 equals 0. Give the general solution. No restriction given. So now we're going to say cos 2x is equal to minus 0,1625. Shh. Learn this. You need to know every one of these examples. So your angle is 2x is equal to shift cos minus 0,1625. I get 99,35. The minute we say shift cos of an angle, we put plus minus in front of it. For cos, we put plus minus, plus k times 360, where k is an element of integers. Now I want x on its own. X is equal to 99,35 divided by 2, 49,7, plus minus 49,7, plus k times, you divide that also by 2. 360 divided by 2 is 180, where k is an element of integers. Shift cos minus 0,1625. 99,35. Something wrong with your calculator, boss. Swallow it. Eat it for breakfast.
Calculator yakho ayina data.
Where you bought the batteries from? Corner shop. Right. Shh. Now watch the next one. Watch the next one. I know many of you have seen this. Now what? Right. Give the general solution. Learn this. What if they told you sine x plus 30 is equal to cos 2x, like that, for 7 marks? It's the last one we're doing before break. Shh. Learn. When you see this, you change the cos to sine. All right, watch how I do it. Put down your pens, otherwise you're going to be lost. Question, answer. Sine x plus 30 is equal to cos 2x is sine 90 minus 2x. Sine 90 will change back to cos 2x. So you change the cos to sine, not the sine to cos. Right, now pay attention. There's an art of doing this. Put down your pens. Grade 11s, we're going for break. Your world famous burgers are waiting. Relax, it's there, ready for the launch. It's on the take, faster than McD's or Burger King. Right. No delays. Even your cold drinks waiting for you. Relax. Right. The minute you do this, that's step number 1. Step number 2, cancel the 2 signs. And the minute you cancel it, now you say x plus 30 equals 90 minus 2x plus k times 360. Or quadrant 2, that's your quadrant 1 answer. Now you say x plus 30 is equal to 180 minus your angle. Now, let's solve for x. Now solve for x. So x equals x plus 2x is 3x. 90 minus 30 is 60 plus k times 360, where k is an element of integers, so x will equal to 60 divided by 3 is 20 degrees plus k times 360 divided by 3 is 120, where k is an element of integers. That's your first solution. Your second solution, x plus 30, 180 minus 90 plus 2x plus k times 360. This is what's going to give you 7 marks in your exam. X minus 2x is minus 1x. 180 minus 90 is 90. 90 minus 30 is 60. Plus k times 360, where k is an element of integers, so x will equal to, divide by minus, minus 60 minus k times 360, where k is an element of integers. Learn this. I beg you, learn this. It is 12:30 on the dot. Guys, we will resume at 1:15. You got a 45-minute lunch. Enjoy your break, enjoy your break, enjoy your break. 45-minute lunch, 45-minute lunch. Testing. 1, 2. Here we go. We are back. We are back. We are back. Are we live, onliners? Are we back? Summit, are we good? Are we live? Are we rolling? Okay, thank you. We back. Hope you enjoyed your lunch. Right, put the heading Euclidean Geometry. Right. Quiet. Guys, this is a topic that most grade 11s, they leave out or they fail hopelessly. Not you. Right. We're dealing. Your Euclidean geometry is broken up into a proof. You got to prove a theorem. You're going to get a circle that will have Pythagoras in it. You'll have a Pythagoras problem. Then you'll get easy. Then you'll get challenge. Thank you, grade 11s. The proof is worth 5 marks. That's your bookwork. Pythagoras will be worth 5 marks. 5, 10. Your easy will be about 12 marks. 5, 10, and 12, 22. And the challenge will be 8 marks. And there's your 30 marks. So guys, it's easy. 5 plus 5 is 10. It's easy to get 22 out of 30. It's very easy. The challenge will come with the 8. We know in a cyclic quadrilateral, all 4 points must touch the circumference. The opposite angles are supplementary. The opposite angles are supplementary. They add up to 180. We know that the exterior angle of a cyclic quad is equal to the interior opposite. Take this down. Thank you. Right. Very important that you're able to pick up the pictures. The next one. Right. The bow tie. Or the scissor. Bow tie or scissor. That angle is equal to that angle. And that angle is equal to that angle. What do we call that? Angles in same segment at the circumference are equal. You walked in late. Sorry. The next one. This is a very important one. Who knows what is this one? Who knows what is this one? What is this one? Yes, equal chords subtend equal angles at the circumference. Come, work fast. Work fast. Take them down. I want to give you all of this, then we can start with our examples. Okay. Shh. The next one. When your bow tie starts at the center of the circle. And 3 points touch the circumference. We know that if this is 20, then that is 40. Angle at center is 2 times angle at center is equal to 2 times angle at circumference. The next one. The spearhead shape. Like that. Like that. Like that. And like that. Join us online. Okay, Mamu. Exterior angle at center is equal to 2 times angle at circumference. Now that one looks exactly like this one here. That one and this one here is both the same theorem. So even if you had a quadrilateral that started from the center and 3 points touched the circumference, exterior angle at center is 2 times angle at circumference. So this and that is exactly the same. Right? Quiet. The next one. Line drawn from center of circle to the midpoint of a chord. Line drawn from center of circle to the midpoint of a chord is perpendicular to the chord. The next one. What is this one called? Angle in a semicircle, yes or no? Right, so a diameter subtends a 90 degrees. So angle in a semicircle is 90 degrees. The next one. A radius is 90 degrees to a tangent. Quiet. Shh. The next one. Right. If you got a triangle and all 3 points, I don't know if you can call it cyclic, but I just call it cyclic, a cyclic triangle, all 3 points must touch the circumference. Then we know if there's a tangent passing any one of the points, tan chord theorem. Angle between tangent and chord is equal to the angle subtended at the circumference in the alternate segment. So tan chord theorem. So that angle is equal to that angle, and then this angle here will equal to that far angle there at the circumference. Right. Right. Two tangents meeting at a common point outside a circle are equal in length to the circumference. Two tangents meeting at a common point outside the circle are equal in length to the circumference, or to where they touch the circle. So remember, whenever we're dealing with triangles, we always look. Now remember, if I join that and I join that, then that is equal to that because of radii, and this becomes a kite. And not only does it become a kite, if I join those two there, that becomes an isosceles triangle. We're going to be using isosceles triangles heavily. So look for radii. The minute you have radii, see what triangles it forms. And in most cases, it will form what type of a triangle? No, we don't spell it like that. Isosceles triangle. Right, let's have fun. Your first 42, 4, 6, and 3, your first 9 marks. All right, they gave you a proof in this paper. They told you to prove the theorem that the exterior angle at center is equal to 2 times angle at. Right, so that's your first 5 marks bookwork. Now we start with the diagram. Right, now I'm going to show you there's an art of trigonometry, geometry, Euclidean. You learn the art, you learn the method, you'll always get it right. Okay, here we go. Right, let's start here, guys. Let's take this one down. Take it down with me. Here we go. GH equals H. So GH equals HE. Now listen, what is important about that? These two are equal. We know the only theorem that we know is that a line drawn from center of circle to a midpoint of the chord meets it at 90 degrees. Yes or no? Right. They are radii OE are drawn. EGF is 55. Right, now watch. We got radii. That's a radius equal to a radius equal to a radius. Basically, I got an isosceles triangle here and I got an isosceles triangle. That's F1, that's F2. So this question is loaded with information. Right. Number one, write down the size of D. With reasons. Write down the size of O2. That's 2. Prove with reasons that DE is a tangent. Prove that DE is a tangent passing through E, F, and H. At E. 2, 2, 2, 3. Mark allocation, 2, 2, 2, 3. Total marks, 5, 9 marks. Now you always start from the known moving to the unknown. You always start from the known. What's your known? What's given to you? 55. Sorry, this is O1 and O2. O1, and that's O2. Take it down. Now, your mark allocation will tell you how easy or difficult is it. If it's 1 mark or 2 marks, it means there's a direct link. If it's 3, 4, 5, it means, hey, I might have to go somewhere else to get to it. So it's a 2-mark question. So is it direct or indirect? All right, so where's the direct? What's directly linked to 55? Angle D. It means, is there a direct link? What's the direct link? The scissor. Angles in the same segment. Check this. Here's the bow tie. There's the bow tie. So if this is 55, the answer to question number 1, angle D equals 55. And then go and put it on your diagram when you're done with it. Go to your diagram, write 55. Angles in the same segment. So done. O2. It's 2 marks. Direct or indirect? So how is O2 directly linked to which angle? It's directly linked to 55. Why? The spearhead shape. Remember I showed you that spearhead, like a spearhead, like a asachai? Angle at center is 2 times angle at circumference. So angle at center, 2 times angle at circumference. So angle O2 is equal to how much? 110. Y, exterior angle at center, equal to 2 times angle at circumference. The size of F2, 2 marks, direct or indirect? All right, so we got O2 to be 110. Now I did tell you radii, here's an isosceles triangle. So if this is 110, that's O2. That side is equal to that side. So OE equals OF radii. Therefore, triangle OEF is isosceles. Right. Therefore, E3 is equal to F2. Therefore, angle F2. Why is E3? The angles opposite the equal sides. So F2 is equal to 180 minus 110 divided by 2. Sum of angles of a triangle. So what is F2 equal to? 180 minus 110 is 70 divided by 2 is how much? 35. And that is also 35. And we know a diameter subtends that whole angle is 90. And if this is a radius, that's a radius, this whole angle is 55. So there's so much. Prove that DE is a tangent passing through E, F, and G. E, F, G, and DE is a tangent. So that means E1, EFH, sorry. EFH. So E1, can we prove that E1 is 35? If E1 is 35 and that is 35, that means tan chord. Let me see. We know that this whole angle is 55 plus 35 is 90. Oh, I can find E2, I can find E. Oh, okay, right. I know how I'm going to get it. Right. Shh. So now, although there's no circle drawn there, but they're telling you there's a tangent passing through the circle EFH at E. So watch. So all you do is you draw a circle around it, EHF. Doesn't have to be a perfect circle. They're telling you there's a circle here. So now we have to prove for this to be a tangent, for that to be a tangent, we have to prove, now here's your triangle in the circle that touches all 3 points. For this line here to be a tangent, we have to prove that angle E1 is equal to F2. Tan chord theorem. Right. So let's find out what is E2. Right. So angle O1 is equal to 180 minus, or we can say O1 is equal to 7. Okay. O1 equal to 70, adjacent supplementary. Angles on a straight line. So we know that this angle here is 70. This angle is 90. H2 equals 90. Why is H2 90? Line drawn from center of circle to midpoint of a chord. Right. Therefore, angle E2, sum of angles of a triangle. How much is E2? Work it out. 180 minus 90 minus 70, 20 degrees. E2 is 20, sum of angles of a triangle. Now, if this is 20 degrees, now we know, right, E1 plus E2 equals 55 degrees. This whole angle is 55 because it's equal to that. Right, the angles opposite the equal sides. Right. So if this is 20, therefore angle E1 equals 55 minus 20. E1 equals 35. So now we prove that E1 is 35. Now E1 is 35 and F2 equals 35, which you proved before. Therefore, DE must be a tangent. And what is the reason? The converse, the opposite of tan-chord theorem. Right, let me just explain to you what this converse refers to. Okay, pay attention here, guys. So, if you got any triangle and you got a line passing here, and this angle is equal to that angle, it means that point ABC, if this angle is equal to that angle, it implies ABCD. Now we can, if this angle, let's call the C1. If angle C1 is equal to A, therefore CD must be a tangent to a circle ABC. That means there must be a circle drawn over A, B, and C. At the, not like that. Let's rather do it like this. There we go. That means a circle can be drawn around A, B, and C, even if the circle is not given. But the mere fact that that angle is equal to that angle, it means that that line is a tangent. Not a tangent to the triangle, but a tangent to an imaginary circle that can be drawn that will touch A, B, and C. That's the converse. The forward is tan-chord when a circle is given. But if you have a line and you have a chord, it's the converse. Right, let's see you guys. This is the common test June 2024 KZN. Where are we? What happened to my pen? There we go. Right, let's give you another one. There we go. Let's go up till there. Let's go from there past there. Actually, let's go more like that. There we go. There we go. D, K1, K2, O is the center of the circle. No, T. T1, T2. That's 40 degrees. That's point Q. This is 65. C1, C2, 25. P1. Let's go. Right, in the diagram, CD is a diameter, PC is a tangent, CDP 40, DPT 20, and TQC 65. Right, Calculate with reasons. Find with reasons. I want you guys to do this one. Number 1, C2. Number 2, angle K1. Number 3, angle P1. Number 4, prove that TC equals QC. Prove that TC equals QC. 2, 4, 6, 8 marks. 2, 4, 6, 8. Oh, here's the Pythagoras one coming up next. All goes well. We're moving at fantastic speed. You guys have been absolutely amazing today. Imagine we spent 2 entire days doing 6 months of work, Saturday and Sunday, and you guys are all here on a Sunday afternoon. Guys, give yourself a nice round of applause. You guys are absolutely amazing. And if we work well, by 2:30 today, you'll be gone. It's 2 o'clock now. We'll do another about 2 or 3 problems and we'll call it the day. Right. Right, let's find out angle C2. Right, come on. You can see 2 marks, direct link. C2 is 40 degrees, tan code. Angle K1, sorry. Angle K1, this is a diameter. So a diameter subtends a 90 degrees. So K1 is equal to 90 degrees. Why? Angle in a semicircle. Angle P1. This angle, here's a triangle, check here. Shh. Thank you, grade 11s. Here's a triangle. Exterior angle of a triangle is equal to the sum of the interior opposite. So P1, I'm going to say 65 degrees exterior angle is equal to the sum of the interior. So exterior angle of triangle equals sum of the interior opposite. So therefore, 65 minus 40 equal P1. P1 equals 25 degrees. Last one. Shh. Quiet, guys. TC equal QC. TC equal QC. So we need to prove, in order to prove that these two sides are equal, we need to prove that their two angles are equal. In order to prove the two sides, their two angles must be equal because it's isosceles. So how do we get Q1 to be 65? How do we get, okay, I know how to do it. It could be 3 marks, it could be 4 marks. How would you do it? How would you get T1 to be 65? Come, think about it. Apply your mind. Come on. Very easy. You got a big, let me highlight it for you. You got a triangle here. Right. You got 90 degrees. You got 40 degrees. 90 plus 40 is 130. So this angle must be 50. Sum of angles of a triangle. Right. Angle C1 equals 50. Sum of angles of a triangle. Therefore, angle T1 is equal to 65 degrees. Sum of angles of a triangle, the small triangle. Now, if that is 65 and that Q is 65, therefore TC equals QC. That's what they wanted us to find. What's the reason? Sides opposite equal angles. You can say of isosceles triangle if you want. There we go, we are done. One more we do and then you're going home. This is the last one we are doing for today. Last one. But this one, you have to do the whole thing. It's 5 and 4, it's 9 marks. 2 questions, 1 for 5, 1 for 4. 2 questions on 1 diagram. Right, are you ready? Right. Last question for today. And then we are done with paper 1 and paper 2. We are done with our grade 11 workshop for June exam prep 2026 for Mitchell's Plain, Cape Town, and the rest of South Africa. Right, here we go. You guys have been absolutely amazing. Right, last one, guys. I think we'll be done by 2:30. See, I told you, we're on time. We finished everything, even 30 minutes earlier. Right. Okay, O is the center of the circle. Let's go from there to there. Right. From here, going straight up there. From there, going straight down there. Guys. From there, coming down there. From here to here. From there to there. No. Boom, boom. From there to there. O. P. 62 degrees. N. 90 degrees. R. 15. 9. S. O is the center of the circle, right? R is the tangent to the circle, R is equal to 15, TS. Guys, they say TS is 9. TS equals 9 units. They want, number 1, calculate the size of NOR. For 5 marks. The length of the radius of the circle. For 4 marks. Right. I'll give you 3 minutes and 2 minutes. I'll give you 5 minutes to answer both the questions. I want you to try this on your own, and then we'll come back and I'll crack it. I'm going for an oxygen break. Five minutes. 5 minutes.
Molweni, ni right? Abantu bebecele ufota izolo namhlanje ngicela bazothatha ifoto zabo khona zidelete. Anazi space. So ifoni uzoza no type C ne because I've got the cable up. Thank you very much. If i-iPhone yakho isebenzisa type C ungaza nayo konke. But if usebenzisa la iPhone yakala leya izolo i-iPhone yanamhlanje isebenzisa type C nayo. Well, kufuneka uze uzokhetha ii-pictures akanzazi ii-pictures. Ukhona usisi bethathe ii-pictures zakho izolo futhi but akazanga namhlanje. But akafunde nawe esikolweni uthe andifuna uyithetha. Yes. Let's come. Ukhona umuntu ongahluthanga? Nibaninzi. Funa nje abantu abayi-8. Okay, ikanza zikhethela kwam. Sezile. Azizwe. Situ. Lesikonezi lesifika namhlanje. Spelling yes. No. Yo, I say I charge you.
This one is this is better than that. Yes.
Awutshintsha iiglasi zam. Nasesikolweni sakho lo mntana ungalazi. Unje nasesikolweni.
Okay, we're back. You can sing at the end of the session. But you all have to sing one song. So I hope you people got one song that all of you can sing together. Why don't you sing that one? Siyabonga, Siyabonga. You don't. All right, you run it rather. Let me shut my mouth. Now, after we're done with this, they're all going to sing one song. Khalid, choose a song for them. Choose one song that they all know together, and then we're going to video it for the whole country, and you're all going to sing it together. Right, wait. Let's finish up here first. Khalid, you can tell him which song to when I'm done here. Right, let's go. The size of NOR. Now we know this is 90. 90. Okay. I'm just trying to. Oh, wait. Now we know that this tangent is equal to that tangent. If this is 62, then this angle here is, because this here becomes an isosceles triangle, that angle is 62. If that is 62 and this is 90, 90 minus 62 is 28, and then sum of angles of a triangle, and we'll get angle O. All right, so the first thing we're going to do, we're going to say OR is perpendicular or 90 degrees to RS. Line drawn from center of circle to a tangent. No, a radius 90 degrees to tangent. Then we're going to say PS is equal to RS, two tangents meeting at a common point. Khalid, did you find a song for them? Because they sang so nice yesterday. Ahia, ahia, oh. All right. Therefore, R1, R2, angle R2 is equal to 62. Angles opposite the equal sides. Angles opposite the equal sides. Now, therefore, angle R1 equals 90 minus 62. Let's go to our calculator. What's 90 minus 62? 28, am I right? Now, in triangle ONR, therefore O equals 180 minus 90 minus 28. Angle O is also 62. Angle O, that's NOR, therefore angle NOR is also 62, sum of angles of a triangle. And there we go, we got NOR, 62. Right, last one, before you all singing the song. Khalid, where are you? He disappeared, he's gone out. Right, the last one, the length of the radius of the circle. So the length of the radius. So TS is 9, the length of the radius. Khalid, did you choose a song, brah? Right, let's go. The length of the radius of the circle. All right, that's 90 degrees. So if this is 9, that is 15. In this triangle here, I'm going to use Pythagoras. No. Okay, if that is 15, that is 15, that's also 90. But remember, TS is 9. So if I calculated the small piece here, wait. 62, I can get this side. No, I can't. Let me just double check. Is it TS? Let me double check that I drew. Is it right? Wait, 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 wait. Shh. NRS. I can find this side. I can find that side.
Guys, please. But disturbing those who want to go to grade 12.
Okay, here we go. Let's try in triangle NRS. NR over 15. Right. So let's start here. In triangle NRS, we're looking at NRS. We want this side here. So that is my that's opposite hypotenuse adjacent. That's a 90-degree triangle. So I want NR. I'm going to go, I can even use trigonometry. I can say cos 62. Cos of 62 is NR over RS. Is NR over RS. So cos 62 is equal to NR. RS is 15. So NR on its own times 15 is 15 cos 62. So NR is equal to 15 cos 62, 7,04. So I get this. Let's do it in a different color. So this side here is 7,04. Right. Now we want the radius. There's the radius. We got another 90-degree triangle. So I can say cos of 28. We found 28 again. So I'm going to say in triangle ONR. I'm going to say cos of 28 is equal to 7,04 over OR. And OR is my radius. That's what we want to find. So now we want OR on its own. So OR over 7,04 equal 1 over cos 28. Let's just double check. Yes, that's correct. 7,04 over OR over cos 28. Let's multiply. We want R. Multiply by 7,04. Multiply by 7,04. The final answer for the final question for today, 7,04 divided by cos 28. And that gives you 7,97 units. That is the length of your radius. Right, wait. I have to record
Wait,
this.
guys, wait.
Wait, I have to record this. I want to hear that the last farewell song for today.
Imani, sanungama.
So yeah,
Ibhasi azikafiki nofiki. Sanungama. Ingoma eyi-1 then sihambeni. Please. Okay. Ivenieza. Nifunephi? Yeah. Ina.
Wa, 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 wathole inziyo ya. Ithola omunye umuntu eyinthana.
Papa yini. If anifuni sinibize bheki scream. Phambili ngewo, phambili ngechimuri, phambili ngewo, phambili ngewo, phambili ngewo, phambili ngechimuri, phambili ngewo, phambili ngewo. Papa yini. Umyeni wakho ngowapi?
South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.